Alright, let's see what we got over here. We have a boy standing on the edge of a cliff. Not the smartest thing I've seen. 20 meters above sea level and throws a stone straight up. Okay, so let me just model this as we go. So we have this cliff, boy, throws a stone 25 meters straight up. Okay, now what we're going to assume over here is that when you throw this stone up, so here we got a stone, goes up, oops, let's draw a straight line, goes straight up, 25, so u is equal to 25 meters per second. So over here we're assuming that going up is positive, and in saying this, we're going to say that this starting point where this stone is going to be 25 meters above the ground. So this over here is, oh wait, sorry, not 25, what is it? 20. 20 is the number. 20 meters above sea level. So let's grab a bit of blue over here. Okay. Now, what else do we have? How long does it take for the stone to reach the highest point? Now, if we want the highest point, there's a few things that we want. Now, the highest point in the first place, this part here means that v has to equal to 0. And let's just solve this first part first, because it looks like there's quite a few question marks over here in this question. So u is equal to 25. We want it to go straight up. And what else do we have? So we got u, v, and, well, if you want the highest point, you want x, right? So x is unknown. And we also have, assuming we're on planet Earth, our acceleration. This is negative 9 meters squared. Just remember that velocity in meters per second. Okay, sorry, did I say meters squared? Meters per second squared for acceleration over here. Anyway, moving on. So we have 3 variables known, x is unknown. So generally, what we're going to be doing here is be using equation 5 to solve what x is equal to. So just moving down a little bit, grab me some room. I'm going to say that x is equal to v squared minus u squared divided by 2a. So just the transposition of this fifth equation. And I'm going to sub in all of my numbers. So this is going to be 0 squared minus 25 squared on 2 times negative 9.8. Okay, bring out my trusty calculator, which, well, is a CAS in this case. Of course, you can't use this in your test. We're going to get, let's see, so 0 squared minus 25 squared. Whoops, that's not square. 2 times negative 9.8. Okay, so we get about 31.9 meters high. Okay, and this positive 31.9 just means that displacement is going up. So we have a upward displacement. And that's how high it goes. So this is for the first part. So this is the max height above starting point. Okay, so when I modeled this onto my problem, just to use for the next part, this is to say that the distance from here all the way up here, where you have your velocity equal to 0, we have 31.9 meters as our max height over here. So it's the extent of this green line, and now it's going to fall back down. And actually, before we say that, how high does the ball rise above its release point? Well, I mean, actually that's what we answered. Actually, what we want over here is how long does it take? Okay, so my bad. Seems like we jumped the gun. How long does it take? Don't think I circled the right bit. How long does it take? Okay, in this case over here, I need to find out what t is. Okay, now we need to find an equation that relates t, a, v, and u. Of course, use x here because we did know what x is now. But I think it would be similar. Sorry, not similar. Simpler to use a, v, and u because if you factor in time, that means we can use the first equation here. We have a linear equation here to solve for t. So let's try that out. So we're going to end up with v equal to u plus at. Now if we're solving for time here, this just means that time is equal to velocity minus u, sorry, final velocity minus initial velocity divided by a. So I'm just going to plug in some numbers here to find out t, because this is just equal to 0 minus the initial output velocity was 25, and it's going to be divided by negative 9.8. Okay, so going back to our calc, negative 25 divided by negative 9.8 will give us about 2.55. Okay. So this is the answer to the question of how long it takes to get to max height. Time for Hmax, call that maximum height. Okay, what's the next part? Not how high. How long does it take for the stone to reach a point 25 meters above its release point? Well, I mean, if let's say what other color can I use first of all? Say orange. Okay, if we say over here this is x equals to 0, what we want is a point 25 meters above this release point of x equals to 0. So what we want is, how long does it take to get 25 meters above? And this is where x is equal to 25. Okay, so in this case over here, we want a displacement of positive 25 meters above the ground. In this case over here, we can't use v is equal to 0 because we know that it doesn't actually reach a velocity of 0 until it reaches the maximum height of 31.9. But what we can use is this 25 over here for x, 25 for our initial velocity, and a is equal to negative 9.8. And we want to know how long this takes. So, this part. This how long just means we need to find out what t is equal to for this part over here. Okay, so given x, u, and a, so we'll just write all of these out. So initial velocity stays as 25 meters per second going up. Displacement going up is 25 meters. Gravity on Earth will not change, not in the near future at the very least. Negative 9.8 meters per second squared. How long does it take? What's t? Now, we need to find an equation that relates all of these. So, looking back up to our constant acceleration formula, we can see that I think this one might just do it. The third equation over here. Okay, and just to rewrite that out, we have x equal to ut plus half at squared, and just plugging in all these numbers, we'll end up with 25 equal to, well, 25 again for u, times t, we don't know what t is, plus half at squared. A is negative 9.8, t squared, t is still unknown. Whoa, another quadratic. Here we go. Okay, so if you want to solve a quadratic, naturally you need to make one side equal to 0. So maybe I'll just make my t squared coefficient positive. So I'm going to take everything to the left. So this means that the right hand side of the equation will equal to 0. And on the left side of the equation, I'm going to end up with 4.9 t squared, so that's half of 9.8, but it's positive now because I've switched it to the left. This 25t will now be negative, and this 25 will stay positive. And since I've moved everything from the right side of the equation, this side is now 0. Okay. Let's see. How can we solve this? Maybe we'll just use quadratic formula. Okay. Of course, if we have our CAS, we can use the solve function, but just for the sake of being restricted to a scientific calculator, we're going to do this. So quadratic formula. So negative b, well, that's going to be double negative of 25, positive 25. So we're going to have 25 squared minus 4 AC. A is 4.9. This one here is 25. Okay. Divided by 2a. So this is 2 times 4.9. Okay. Alright. Let's see. Let us consider the positive case. So we're going to add this surd over here. Now, actually, let's think about what that surd is even equal to. Yeah, actually, you know what? Maybe we'll just plug it in. So we get 25. So bring up the fraction. 25 plus the square root of 25 squared minus 4 times 4.9 multiplied by 25. All of this is over 2 times 4.9. See what we get. Over here, looks like we get 3.74 approximately. Okay. Alright. Oops. Okay, we'll just put in units last. Or you can consider the negative case. Now, you're going to expect a negative time value here because we are subtracting by the surd. But let's just double check, just to confirm. Oh, actually, maybe not. Maybe not. So this is 1.37. Okay. So after either 3.74 seconds or 1.37 seconds, it seems that x is equal to 25 meters. What does this mean? Let's have a look at the question. Okay. So if you want the stone to be 25 meters above the ground, so not above the ground, above this release point over here, where this chap over here is throwing up the rock, this means that there's two possibilities for this stone to reach 25. So first of all is the journey up. So maybe we'll just draw the diagram over here. So if the release point is here, so this is where x is equal to 0, just make myself a bit of room. X is equal to 0 over here. If you go up, and say this is 25 meters, then you've reached a point where x is equal to 25. However, as you go back down on the journey down, so it's going to first of all go up to your maximum height, so you get to your h max. Cannot spell. Okay, going to go to your maximum height, goes back down to x is equal to 25. So this means that after the lower time duration, the 1.37 seconds, this refers to the journey up. That after 3.74 seconds, the stone would have went up, back down to where x is equal to 25. So to answer the question over here, let's just double check. How long does it take for the stone to reach a point 25 meters above its release point? Well, if we're talking about how long it takes to just reach this point, then you can say it just takes 1.37 seconds. To reach it a second time, it would, well, take an additional around 2.3 seconds more to get to have a duration of 3.74 seconds overall to have the stone come back down to a displacement of 25 again. So for this question, it takes this long, 1.37 seconds. And to address the very last part, calculate the velocity of when it hits the water. Well, it is a long question. Okay, so how long does it take? Now, let's have a think about this. If we look at the diagram, first of all, let's think about which part of the diagram to use. Now, we've drawn over this quite a bit, so perhaps we will redraw everything. Okay, so we got cliff, dude, stone goes up by 31.9 meters up. Of course, we need to remember that from here to down here, this is 20 meters. Okay, so in other words, initially, the height above the sea, so remember that this over here is the sea, the height above is actually the sum of these two, which is 31.9 plus 20. So that means the situation we're analyzing is how long does it take to get from this point over here all the way down to the sea level. Okay, what did I press there? All the way down to the sea level and hit this sea surface over here. So for x is equal to 51.9, so this is saying that I want to displace it by this many meters in the downward direction. We also know that when the rock is up over here at its maximum height, it has a velocity of 0. So this means we can say our initial velocity is 0. And we also have an acceleration of, well, gravity of the Earth, which is negative 9.8 meters per second squared. So if you have these three variables and you want to find out at this point over here, what does our final velocity equal to when we hit the very bottom over here? So to find this out, we can again use the fifth equation. Pretty much done this to death by now, so we can record that v squared is equal to u squared plus 2ax. And if you want to know what v is, it's really just the square root of the right hand side of the equation. So let's just plug those numbers in. U is 0, squared out if you want, doesn't really matter. So you have 2 multiplied by negative 9.8 multiplied by our downward displacement of negative 51.9. And doing the math over here, we get 2 multiplied by negative 9.8 multiplied by negative 51.9. This gives us about, whoa, it's quite fast, isn't it? Let's quote that number again, 1017.24. But wait, does that make sense? Let's have a look at our equation over here. A couple of other things. Alright, calculate the velocity of when it hits the water surface. Wow. Wait a sec. Well, of course that doesn't make sense. I mean, what we found down here is actually v squared. And so we've got a square root this over here. So v, now when you square root 1017.24, this actually gives you two solutions, doesn't it? Whenever you square root a number, or whenever you square root both sides of an equation, you actually end up with the positive and negative solution. So you get plus or minus, what was it? We don't want that. 31.89-ish meters per second. But do we want positive or negative? I mean, in most cases so far we're thinking, well, just take the positive one, negative can't be right. But remember, our stone is going downward. And going downward means that we have a negative velocity. So this means that we actually need to take the negative solution over here. So this means that we say that it has a final velocity of negative 0.89 meters per second. And this is negative because it's traveling downward. So stone moving down. Okay, that was a big one. Alright, hope you enjoyed that.